Hey, Oakham students, Ben Asman here. Time for a little tender love and care for your thin layer chromatography. That's right, we're doing TLC. Let's get to it.
Thin layer chromatography. Though it can be used for purification, we usually use it for determining whether or not you got your product. And how pure did that product come out? We start off with a thin piece of glass or plastic when we're cheap, which we are, covered in a polar stationary phase, usually silica gel. We mark the baseline with a pencil, as well as 3 hash marks for where we're going to have our compounds. Then we're going to apply a small amount of the 2 compounds we wish to compare. In this case, I'm putting a polar compound in blue on the left, and a nonpolar compound in red on the right. The middle will be dotted with both the polar and the nonpolar compound, hence red plus blue equals purple. We put the whole thing in a development jar with a mobile phase to push it up. Notice I use a squiggly line to indicate the solvent front. That's how far the solvent has traveled up the TLC plate. As we see the spots moving up the plate, you'll notice that the nonpolar is going much faster than the polar one. This is because the polar is interacting more with the stationary phase. Now I use colored dots, but a lot of times you can't see the compounds as they're moving up the TLC plate. We solve this by visualizing the TLC plate. To do this, we have different kinds of stains, UV light, powdered iodine, but once we see it, we gotta calculate the RF value. The RF value is just basically a percentage of how far up the TLC plate it went. To calculate it, we're gonna take the solvent front distance. In this case, I said 7.2 centimeters. And we're also gonna take the distance to your compound. In this case, I chose the red dot, let's say 5.1 centimeters. Distance to compound over distance to solvent front, we get 0.7. Notice RF values, just like percentages, do not have units.
Okay, one more quick thing for us to discuss is that if you spot this, and for us in this case, I have here standard number 1, unknown, and a co-spot. And so if you spot this, that means standard number 1 here, and unknown here and there, and it runs up and they all line up on the same RF value, then we can usually say that they're the same thing. Not guaranteed. This is normally for our lab it is, but in reality this is not guaranteed. We just know that's the same polarity, and so that's pretty close. That's good. That's what they would look like. That's how we know it is. However, if we do a different standard, here we standard number 2. So once again, standard number 2, 1, 2, and standard and the unknown 1, 2. So we have a co-spot in the middle. That's both. Okay, and we can see, and we end up with 2 different RF values. One for our unknown and one for our standard B. This means that they're different. Now, they in this case lined up this way. They could have lined up the other way. It doesn't matter. All that matters is they're offset from each other. We know they're different. In this case, we can say that the unknown is less polar than the standard number 2, and that it is probably standard number 1, whatever that may be. Now, I did want to warn you about one other thing, because we will have other balls of solvent around, is what happens if you change the mobile phase, you change the solvent. Well, in general, if it's a more polar solvent than you were supposed to use, your spots will end up much higher. That's just because, like before, like dissolved like, and so if you have a more polar solvent, it would like to spend more time on the polar stationary phase, and thus it outcompetes our product, and our product ends up spending more time in the mobile phase. So if our mobile phase wants to be on the stationary phase, our compounds can't be, and they will be in the mobile phase, and they will go up higher. And if our solvent is less polar, it does not want to be on the stationary phase. If our solvent is less polar, it doesn't want to be on the stationary phase. Therefore, our compounds spend more time on the stationary phase, and they will go up less. Okay, now how do we go into doing this? Okay, first thing we're going to need is a TLC plate. Prongs. Grab one of these. We want to try and avoid touching them with our hands because our hands do have oils which will show up. They have a matte side and a shiny side. You want shiny side down. And now you're going to want a regular pencil, not a mechanical one, because that will cut into the silica gel, and not a pen, because that will, well, that's organic, so that's just going to go up the sides. Now, I recommend, because you're new at this, you give yourself a good centimeter. That's about a finger's width. And then for our very first one here, we are going to be doing 3 marks. Now for this one, we're going to have the P hydroxyacetylphenone, and the O-hydroxyacetylphenone. Of course, this is also known as 1,4 and 1,2. But and then we're going to have a co-spot, which I always like to use B for both. We are going to grab ourselves a capillary tube. This is one of the thinner ones. It's open at both ends for the TLCs. For this, you want to put one hand down here, put the other hand as a pivot. You go up and down. You want to try and just touch and retreat. Touch and retreat. And we'll do this from another angle so you can see it that way too. Touch. So we're going to do touch and retreat, and then we want to do the co-spot as well. Okay, I'll do it one more time from here. So maybe that's seen better. And there we go. The smaller your spot, the better this turns out. There we have the second guy. And touch and retreat. One more time. A different angle. Hopefully you'll see it. Touch and retreat, and then in the middle, touch, touch. That's all it takes. And our TLC is prepped. Next, we are going to need one of the TLC development drawers. That's this one. For that, we will also need a wick, essentially just a piece of filter paper which we stick right in there. And now for this one, we are using the 3070 mix petroleum ether ethyl acetate. Notice this is 3070. That means it's a whole lot less ethyl acetate, a whole lot more petroleum ether. That means very not polar. And for this, we will need 2 to 3 mils worth. Toss that in there. Take this, swirl that around, make sure that that is covered, and all you have left is a tiny puddle at the bottom. Next up, we can open this, grab our TLC plate, take that, and while holding it like this, bring it as close as we can to the puddle and then drop it in. We should get a nice flat bottom. If it goes up on, if you put it in crooked, it'll go up sideways, and that's not what you want. But we want to keep the vape pressure high, so we're going to put the lid on, and it's upside down. We don't want to touch it, we don't want to move it, we don't want to look at it weird, we just want to let it go. Okay, while that's developing, let's move over to the standards. Now, save time when you're collecting your samples for your unknown and for your standards. What you should really do is get each one of the standards in a small vial, just like this, and share it between every 2 people or so, maybe 3. That way you don't end up lining up forever and wasting a lot of time. And of course, each one is labeled with a Sharpie. The Sharpie will come off with a little bit of acetone later if you need it. These are, of course, all in DCM. We have here caffeine, acetaminophen, naproxen, and ibuprofen. Okay, while that one is running, we want to grab ourselves another TLC plate. These are both demos for you guys, so you're not necessarily going to have to do this, but you should know where these end up. And so for this one, we're going to use, we're going to need 4 marks. So once again, I'm going to put about centimeters worth, and we're going to put 4 marks. Notice I'm going very light sideways, so I don't want to mark it. So our 4 standards for this one are going to be caffeine, acetaminophen, naproxen, and ibuprofen. And so here they are: caffeine, acetaminophen, naproxen, and ibuprofen. We're going to need a different one of these for each one. Here's our caffeine. Just touch a little bit there. Again, touch. Trying to do this so you can see within camera. Touch, touch, and that's it. repeat for all of these. Did have a little bubble there, so touch that. That's it. I'm gonna go a little heavier actually on the ibuprofen because that one's actually really hard to see sometimes. Now to pull out our first TLC. Okay, that looks just about done. We could have gone a little bit more, but that will do for now. You can see here is the mark. We want to quickly mark that. Take that here, and we're going to mark the solvent front. I can still see it just about there. That's where our solvent front was. Okay, here's our TLC. Bring that in. Bring in our source of UV light. Turn that on, and lovely. We can now take our pencil and easily mark where our spots showed up. I will have another frame at the end with all of them so that you can use that.
But as for right now, let's go back to developing the Analgesics standards.
And again, we're going to need a development jar, either with a fresh wick or a dry one at least. This time we're using a different solvent system. Notice it's 70-30 instead of 30-70. That means that there's a whole lot more at the last state, means it's far more polar.
We also have a little bit of acetic acid in there just to reduce streaking.
Make sure you don't mix these up. And then we're going to need 2 to 3 mils worth. Toss that in just as before. Close and roll around. Make sure it's saturated and have a tiny little pool left at the bottom. Cap upside down. Grab our TLC plate. Here's this. Lovely. We're going to put this sideways. Stick that in. Cap on. Wait for it to finish. Try and avoid moving it. There we go. We can just see the mobile face starting to climb. It's pretty straight.
While that's developing, let's move over to the unknowns.
So now what you guys are actually going to do is you're going to test these, your unknown versus the standards, each one individually. So in this case, my unknown is going to go right there. My co-spot, which I'm going to put as both, will be right there. And I think that I'm going to test ibuprofen. And I'm going to do one more of these. You might have to do as many as 4, depending on how your guess is. But I'm going to be testing. Once again, we have the unknown. We have both, and then I don't know. I'm going to try caffeine. So here's my unknown. Cap 2, and this guy's, I'm trying to save some time. I'm going to do both of these at once. So 1, 2, 1, 2, 1, 2, 1, 2. Yep, that one didn't quite get that much. Do one more. That should be plenty for us to see that. If you're never not uncertain, you can always bring the UV light in and see if you can see your spots. And then of course, I'm going to need the caffeine. 1, 2, 1, 2. Okay.
And the ibuprofen.
Lovely. Always do the co-spot second because you don't want to risk contaminating the original.
Let's check back in with the standards.
Okay, that looks about done. Come here, take that out. You can see solvent front. Put that down there, and we're going to mark that. Lovely. And here we go for this. Bring in our source of UV light. Lovely. And we can see our 4 spots. One right there, one like there. It's a little streaky, but don't worry about the streak. Mark the spot, that's what you care about. One there, and one there.
Okay, let's quickly develop the ibuprofen on the right and the caffeine on the left. As before, we want to gently put it in, put the lid upside down, and then not touch it until it's done. Okay, let's speed this up because it's going to take forever otherwise. And cool.
Okay, so here are the two I gave a shot to, and here are the two starting stuff. Okay, so definitely spot here, spot there, spot there, spot here, spot there, spot here, spot there, spot here, spot there, spot here, and spot there. So looking at this one, now there's definitely two things in my known. One of them does look like it's caffeine because we have 1, 2, 3 in a row here. So it is caffeine, but it's not, this is not caffeine. This one is. So we have caffeine here. So here, once again, we see two sets of spots for a known mix. But then this one for ibuprofen, that doesn't quite line up. So that's got to be something else, okay? Which means probably the naproxen, but we're going to want to have to run one more of these to check. That's as far as I'm going to do, because the whole point is for you to learn how to do it. You can calculate the RFs of these. So from here to there, and from here to the center of a spot, one for every row of spots. One there, 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 and there, and there, 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 and there. These two are a little off until you just kind of find the center of the two of them. Cool? Cool. If you're not sure what your thing is, make sure you run another TLC plate to check. If you do, just write it up and you're done.